Hello everyone, welcome. Thank you for joining. My name is Riley and I'll be hosting this technical webinar for you today. Before we get started, I'd just like to run over the notifications and sounds in Blackboard. So if you'd just like to go to your notifications you'll find it where the cog symbol is, and just go to your notification settings. It's a drop down, and then untick all of the boxes underneath the notification settings. That'll just make sure you won't receive any pop-ups, sounds, or notifications during the session, which can be annoying. Now, today's technical topic is digital engineering for rail, which is being presented by Dr. Daniel Faraji, who is one of our lecturers with us at EIT. Now, everyone in this session, everyone registered for this webinar will receive a copy of the PDF slides and a link to the video recording via email, and they'll likely receive that either this afternoon or it is an extra long weekend here in Australia, so it might be Tuesday next week, but I'm hoping that you'll receive them by the end of today in a few hours' time. We do also provide a free digital certificate of attendance for this session. So I will be providing a QR code and a link to a short form or survey that you need to fill out in order to receive one. And I will send those out once I'm able to. So briefly about EIT, we are an engineering specialist education provider. We have a range of engineering courses, such as short courses that we call professional certificates. We have diplomas and advanced diplomas in the vet sector. And then we also have a range of degrees, such as bachelor's, master's, and more recently a Doctor of Engineering. We also have undergraduate and graduate certificates. So those courses are in the higher education space. We have industry-oriented programs, so our courses are regularly updated to stay relevant with the industry and make sure that you graduate with the outcomes that you need to be able to work in the real world. We have world-class Australian accredited education. So all of our qualifications, both in vocational and higher education, they are registered and accredited in Australia by the Australian government. However, we do have programs that are also internationally recognised under the three international engineering accords, so the Sydney, the Dublin, and the Washington Accord. You can find more information about our accreditation on our website. We have industry experienced lecturers, so not only those who are involved in academia, but we have lecturers at EIT that are also heavily involved in the industry. We have many lecturers working full-time whilst lecturing for us casually, and they're from all around the world, and they can apply their real-world experience to their teaching as well. We have a unique delivery model, so that includes live and interactive webinars, very similar to what you are in today. However, this is quite a large session. There's already 125 of you already. If you're studying with us, if you're a student at EIT, we have small class sizes, and our webinars are interactive, so it's more you can interact with your lecturers and your peers using your microphone and the chat box, and so that's if you're studying online. We have our international pool of expert lecturers, our dedicated learning support, and state-of-the-art technologies such as hands-on workshops, remote laboratories, and simulation software for you to use. So the agenda for today, so I've just introduced the session, and I'll hand over to Daniel shortly, but we'll be going over information management, building information modeling to digital engineering. We'll be covering what is digital engineering, some standards in digital engineering and its application for rail. And then we'll finish off the session with a conclusion, and we'll also have a short Q&A session. So if anyone does have any questions for Daniel, if you have technical questions, then we'll include that in the Q&A. And if you have any general questions about EIT or our webinars, then I can answer those for you. Now, I'll hand over now to Daniel Faraji. Thank you very much, Daniel, for being willing to present today. And yeah, if you could just briefly introduce yourself, that would be great. Thank you.
Thank you, Riley. Thank you, everyone that joining us. Good afternoon, or I guess I should say it's good morning to somebody that joined us right now. Just briefly, my name is Daniel, and I'm graduated as a railway engineer. And basically, I love engineering, railway engineering. But I've decided also to continue as a disaster risk management, and also right now I received my doctorate of business administration, DBA. Thanks to COVID, it was a good chance for me to update my study and also my backgrounds. Also brief introduction about my career. Right now I'm a member of development group in RISB. Maybe you know that Rail Industry Safety and Standard Board in Australia, and also specifically I'm right now involved in IS 7517. I've been a metro system project manager in more than 7 metro projects, and now I have 15 years experience in railway market. So I joined EIT in November of 2020, and I'm glad to have all the 137 people here, and I hope that we have enjoyed session together. So guys, if you can clearly see me, if it's possible, may type number 1 in the chat box, then I can start confidently. Okay, so everything fine. Thank you guys. So what is a digital engineering? Thank you, Thomas. Thank you. One framework that we call it digital engineering. It has a lot of definition right now in the industry. If you Google it, you can find more than billion pages maybe about the digital engineering, and also it is a trend right now in every sectors. Hopefully in the railway in Australia we start, and we are front runner in the not only, for example, using, but also the standardization is right now very nice in Australia, and also it can be huge development in the industry. So as I said, one framework, many implementation we have. So the digital engineering, we can, for example, summarize it as a collective way of working using a semantic data management, and also enable some more productive methods, and all, or for example or project delivery and asset management. So guys, I'm seeing that some of you have some question, as if possible write in the chat box. At the end of the session I will answer all of the question, if possible, if we have a time, or for example maybe we can answer them via email if you put your email there. The rail sector right now has a lot of needs from the government side, from the project side. So they are thinking about how to digitalize and also how to implement new digital technologies in these sectors. So based on the we need to have for example this chance to enhance the experience and also improve the service to our customers. So we need the digital engineering to collaborate and empower our assets and also our management. So by the, for example, some statistics, if we implement the digital engineering, maybe we can save 25 to 30% more in the asset management cost, and also even in the project in the time-based cost by using them. Many of you maybe knows something about the BIM, and also digital twins. We had previously a lot of very useful and also informative webinars before in EIT. By the way, digital engineering is a concept that we think that it's more generic and it's more comprehensive than, for example, BIM or, for example, digital twin. So it's a one concept. We are using that. So in the traditional information management, we collect the data. We use the directories. We think, for example, gather everything in the one island, and also the delivery things was different right now. But by the way, as the systems getting more complex, we need to improve our management in the data. So the data management and data modeling should be in near future have seen one next revolution in our opinion. In Australia, we are thinking, and also we are developing a benchmark and also useful standards for it as a national base, but even we know that it has internationally renewed also as a beam. So we have, for example, around 20 years experience. So what has been challenges with the traditional information? They were document based, they were disconnected between the database, and they were manually updated specifically. So they were also ad hoc and also subjective. They are related to the individuals. If, for example, one guys do their jobs well, so we have a lot of gains from in the one project, but in the other project maybe parallel of that depend on the one people or a group of the people and team. So maybe we don't gain as much as possible. But in the meta data managing systems, we independent of the software and also in the subjects. So we are no matter, for example, we influence less than previous and traditional version of the data managing systems, and also it's they were not repeatable. So we can, as I mentioned, we have good experiences and also a lot of bad experience, and it depends on the, for example, statistics by the PMBOK, PMI organization. More than 40% of the project fail in all over the world, and this is the huge number. So and they terminated. They don't even see the, for example, inauguration phase and operation somehow. Just go to the other slide. So then we need we feel that we need for the structured data from the past, So the digital transformation has been become a trend among the experts, and over the past 20 years, major part of, for example, comes from rise from the US and also UK. By the way, just as an example here, UK government committed to the building information modeling BIM. So there are different definition for BIM. Somebody said building information management, and also modeling, something like that. They have vast terminology of the BIM. Here we use it as a building information modeling because of the standard. Also, we will introduce them later. So it's exactly the terminology that used on the ISO 19650. So this policy also set a new direction for the industry and was a catalyst for the new ways of working. So that's me. Okay. So here is a visualization how we think BIM and also what is the beyond the BIM. From our finding, also new trends, digital engineering is beyond the BIM. As I told you, maybe for example the first picture that we come to our minds when we hear the digital engineering is a BIM, but frankly digital engineering is beyond the BIM concept. So just as a if I want, for example, show as a first generation of the digitalization, for example, we draw some paperworks and you start to use the CAD file in the CAD, in the AutoCAD or any other CAD software. We start to draw the sketch. We have, for example, some 3D models or 3D view, and also in some cases, for example, we had cross sections and something like that. But by the way, we developed the systems, and in the next step we comes to the visualization. So in the visualization and also 3D software, the 3D geometric modeling. So we have the 3D model, and also the model has some attributes like the dimensions and also the color. Then we have a very huge revolution to that we call it smart 3D modeling. It was what we call BIM, and also what we know BIM right now. In the BIM we have more attributes, and also the model can be updated easily and also linked to some back database. But this database just have a backup. In the digital engineering, if we have more databases, if we have for example link the BIM with the cost, link the BIM with the timing in the project, we link the BIM in the asset management. So and also these databases can be interact with each other. So we call it digital engineering, and also it's a smart databases. It's not the modeling is a part of the digital engineering, and also digital engineering is a whole concept for what we are aiming right now. So guys, everything fine? I just want to know your feedbacks. The voice is clear. If you can type in the chat box number 1 or thumbs up. Okay, thank you, Dr. Asiye. Okay, nice. So what is the digital engineering? We as a terminology, we defined the digital engineering in the past slides, but it's a foundation element for building. It's for example, for building digital twins, building smart infrastructure, building smart cities. So it's a foundation, it's a base for our modeling. So as you can see, only one part of the our in this picture, only one part is the 3D beams that, for example, we have some software developed right now, AutoCAD beam or something like that. By the way, we need to connect the databases with the, for example, time. It's a 4D beam, also known as a 4D beam also, or 5 become adding cost on it. It's become 5D, and also asset management. But from here, for example, the standards doesn't develop till now, and we will introduce the Australian record in this case in the next few slides. So when we link them with the 2D GIS, and also we have a document management, and also add some requirement management and risk management, we can say we have a total solution for the digital engineering. Thank you guys. So what is the concept? Okay, what is the digital engineering, and also what is the differences between the previous data sets? As we said, we had directory previously, but right now we are focusing on the smart databases. Even in some projects, for example, we have in the different steps of the project, we have a directory, we have a file management systems, so on. And also, by the way, we, for example, here we have a different parts. All of them have been developed in all the projects right now as a file management systems. But what we are looking in the digital engineering is that to link them in a smart way, and they can interact them, and changing one items also update the other items, and also key parameters in whole data set, or we can say, for example, meta database management. So here are the key enablers for digital engineering that we have in our modeling, in what we are looking for the stage 3 as a management of the digital engineering for assets in railway. We need to open data formats. It could be, for example, Excel file, documents, the Office for Office, and also CAD files. We have metadata that are, for example, semantic interoperability, so they connect the database to each other, and also then build up the connected digital ecosystem that we call it CDE 2.0. This is the link between the database, and also this is the key elements that we are keen to have in the data digital engineering. Then when we have combined all these 3 key enablers, so we can say we have a digital engineering and a structured data, metadata, that they are connected digitally in one ecosystems. That right now we are using the second generation. Previously, for example, as a beam, we have also connected digital engineering, but it was the version 1. Right now we are developing the second generation. So as we discussed previously, well-known international standard for the beam was ISO 19650. So ISO 1960 was and still is a suitable international standard for the BIM modeling, and also to it improve the information management over the life cycle of the building and civil works. By the way, we know that also background of the ISO 19650 was the UK BSPAS 1192. So that's for example based on fundamental of the structure of the ISO 19650. And also we know that the primary intention for this standard was those involved in the procurement, design and construction or commissioning of built assets, for example one railway lines or one metro project or one maintenance depots. So and also those involved in the operation, they hand over the project from the construction contractors, and also they want to operate it. So they were the most user of this standard. By the way, for example, the governments are maybe don't keen to, for example, use or establish something like this in their projects, or for example force the people to have for example obligation to care about these standards. And also ISO just matured in the stage 1 and 2 as described in this picture. So in the stage 1 we have a national standard, and also stage 2 we have regional or national annexes for in the ISO we had. And also in some parts also ISO mentioned the common data environment, CDE. This is the first generation, as we said, but we are looking to the connected digital ecosystem. We call it also CDE 2.10. So, and also we are looking to implementation of development of project, and also our management, data management in the stage 3. So in the stage 3 we have also big data as in the information layer. By the way, in the standard layer we had a lack here that in Australia we have developed recently OS 7754. So we are keen to do that. So in also in the digital majority of the ISO, as we said, that they have a 3 stage. So the stage 2 maturity was the like this level is the maturity of this standard. So but this standard don't provide further detail on the roadmap or expected timeline of the process on the stage 3. So also they don't provide the possibility of the possible solution to improve digital maturity beyond the stage 2. So many people think that they want to develop this standard more. Even also in the ISO 19650 the stage 3 presented, but we need to know, for example, to have a introduction of the big data, introduce of the object-based serve information model, and also shift from the information container as a document management, as a file management, to the use of the databases. They are defined, but we don't have any guideline, and also some methodology and process in this standard. So in Australia we developed AS 7739.1 recently. It is under the public commenting procedures, and also maybe published in the June or July. as an official process. So in this is specifically for the rail, and also it doesn't develop from the scratch. It's a base of the this standard is the ISO 19650 series, but we developed there in this case, and also it has been have based on the for example has the based on the what we have in the ISO standard right now. So what are the key structure and key topics in the AS1 AS7739? So we have developed till now the key concepts: data management, that it's for example the audience is every people that in the sector of the railway. We have a metadata to support digital engineering, and also data modeling. All have been covered till now in the part 1 of the IS 7739. By the way, the part 2 is under the development, and also the business setup, project planning, project delivery. They are all in the publishing process, and by the way, at the end of this year they will hopefully published, and also in Australia we will have a national standard about the digital engineering, which is also good news for the projects. I will told you why it is good news, because as you can see, the process and also subject and key topics need more staff, need more skilled worker to implement in the project side, in the tender side, in the operation, and also the asset manager sides. So asset owner right now, for example, like RIS, like ARTC, those people that are we call it locally infrastructure managers, IMs. So they are those people that are they need the modeling for the conceptual data, and also they need master data, and also they need general special list entities. So all these subjects can be mapped to a huge workforce for future of the railway in Australia by implementing the RS 7739. And in these cases we need to also, the railway engineers need to develop themselves, or they need to update themselves, and in these cases also we are developing some quick courses in EIT. They are launched right now as a graduate certificated, 3 different courses. Back to the standard. So thank you guys for explaining some big data in the chat box. So the key concepts, as you can see, we are right now forgetting the document management as a traditional. We are looking and also shifting to the data management. This is that, for example, data sets and databases. From the databases, we need to go to and also seek the metadata. What are the metadata? They are semantic, they are ontologies, so they are connected, the key elements to each other, and also what is the map for this connection is the data modeling. And the data modeling is very interesting. We have for example one sort of the data, but one of them is the key element, key parameter. and in these cases, how, for example, this key parameter linked the different databases are described and also are discussed in the data modeling procedures. But for the other concepts and also other among the other 12 headings that we have in the IS 7739, we will also business setup. In the business setup, we are dealing with the conceptual data modeling, that they develop the conceptual model to map and the key data entities and other relations. And then we have a master data entities that it is for the some key parameters, and also standardization data entities, attributes, allocated attributes, names, and also, for example, some values on in this the complete digital ecosystems. After that, with general and specialist entities phase, these consist entities and also attributes required here to support project-based data exchange, and also think that, for example, this data can be easily exchangeable. For example, the asset management systems can be linked to Primavera P6 scheduling by the scheduler. For example, it can be connected to the cost management systems that we have. All the data can be interoperable to each other. This is the goal that we are in the business setup by the asset owners or infrastructure managers follow up right now. And in the project planning also, as we need to develop the project scope and scope up the project database in this in the next steps, and also project data model should be built up, and also it is very interested for the also infrastructure manager to that the per project contract or create this data modeling one assets for this for themselves that can be also updated in different projects. Yes, Rob, presentation is recording. Project also in the last steps are as a project delivery, we are care about the project procurement. For example, engaging the delivery partner responsibility for delivery scopes and including project data sets, and then overhand and also as one of the key deliverables to the client side, to the operator side, to the asset owner side, infrastructure managers, and also then they use it as a CD 2.0 as a connected digital ecosystem that linked all the databases together and also updated it. For example, as we said, that we also add risk management log file to our assets in this system, as we know that, for example, risk logs are the live document in all the projects. It will start from the basis until the end of the project. So in these cases, we can easily update every data that's related to the risks management and also related to the cost management, to the other key function of the one project that we receive from the construction sites to owners, and also we can care about the data management and also information flow management system. So guys, this was the end of my presentation. Just I want to add, as I told you, just 2 or 3 minutes to speak about the I have mentioned that in future we will, for example, need the connection between our databases that we have, and also this should be flexibility in these data. So this can produce more than 30 new jobs as we have our rail project. For example, the project managers should know about the databases. They should care about how to link their island bases, data sets or database that they have right now. And also they need more skills and more qualification. They need, for example, digital value engineering. They need also risk management and safety management in the new era. So we need to develop our skills in these cases, and also think about the new roles and also complex roles and teams activities with each other. And also the rail project roles and teams typically siloed with the low levels of the data sharing and reuse or low maturity digital collaboration right now. But by the way, by the implementation of the connected digital ecosystems, CDE 2.0, we enable the data sharing, we exchange and reuse them. We also through incremental business integration, we can achieve these enabling skills for the project management systems, and that we are right now.